Hey guys, it's Mr. Zigner again. It's lesson 2-6, multiplying integers today. Let's get rolling. So here we can see when we're multiplying integers with different signs, in other words, one number is positive and one number is negative, the product of those two integers with different signs is negative. The examples there, you have 6 times negative 4 is negative 24, and negative 5 times 7 is negative 35. Now I created this extra problem, 4 times negative 3. I wanted to show you just why a positive times a negative is negative. I don't know if you know this, but multiplication is simply repeated addition. So really we're adding 4 negative 3's together. That's what 4 times negative 3 means. So I have 1, 2, 3, 4 negative 3's. Well, if we work our way through this, negative 3 plus negative 3 is negative 6, plus another negative 3 would be negative 9, plus another negative 3 would be negative 12. So there it is. That's why a negative times a positive is a negative, because you're really having, in this case, 4 of those negative numbers added together. 4 negative 3's added together is negative 12. So I hope that helps you understand why a positive times a negative is actually a negative answer. So here's our first example. We have 3 times negative 5. Now again, if I were to really spread this out again, what that means is that there are 3 negative 5's being added together. Well, negative 5 plus negative 5 is negative 10, plus another negative 5. Now we have negative 15. Of course, if we can simplify that by just using multiplication, we're going to really save ourselves a lot of work. So we just use our multiplication table. Well, of course, 3 times 5 is 15, but as we learned on the previous slide, a positive times a negative is actually going to equal a negative answer. So we have 3 times negative 5, and that's going to be negative 15. All righty. Now we have negative 5 times 7. Well, I don't feel like adding up 7 negative 5's. That's going to take too long. So I think we'll just simply use our multiplication table. 7 times 5 is, of course, 35. But since the 5 was negative, when the signs are different, the answer is negative. So our answer here is negative 35. Now, what if those integers are the same sign? Well, the product of two integers with the same sign is positive. So here you can see the two examples. You see them in there? We have 2 times 6 equals 12. Well, that's like you've been learning since 3rd grade. That hasn't changed. I think you start multiplication tables in either 3rd or 4th grade. I believe it's 3rd. So 2 times 6 is still 12. Things haven't changed. But here we have negative 10 times negative 6. Well, that ends up being positive also, and that's the one that sometimes tricks students because you have two negative numbers. How can the answer possibly be a positive? You understand that 10 times 6 is 60, but how is negative 10 times negative 6 also 60? To try to give you an idea, this is the best thing I could think of, to show you why a negative times a negative is a positive, because that's a weird one for people to really understand why. Hopefully this little example will help you. Just thought of this a little bit ago. From the previous slides, we already know that 2 times negative 3 right here is negative 6. All right. And 1 times negative 3, well, that's easy. 1 times any number is that number. So that's our identity property of multiplication. So 1 times negative 3 is negative 3. Of course, 0 times negative 3, well, 0 times any number is, of course, 0. But let's pause here for a second. And do you see the pattern in the answers? Can you figure out what's going on? Last chapter we had this one lesson where we were looking for patterns. How are these numbers increasing? What would be the next number in the arithmetic sequence? How are we moving from negative 6 to negative 3? And is there a same number we can add to go from negative 3 to 0? Well, you probably guessed it already, right? We're adding 3. We're increasing by 3. Negative 6 plus 3 is negative 3, and then negative 3 plus another 3 more brings you up to 0. So without even really looking at the next two problems, I think I can predict what the next two answers are going to be. 0 plus 3, well, that should be 3. And if I add another 3, this 3 right here, plus this 3, that's going to get me 6. Oops, I meant to write that in blue. All right, so now let's actually look at those problems, and you can see here's why a negative equals a negative. As we followed this pattern from top down to bottom, and we kept increasing by 3, you can kind of see how we flow from these negative numbers past 0 right to these positive numbers, just following this logical pattern. So we end up with negative 1 times negative 3 actually ends up equaling positive 3. And of course, negative 2 times negative 3 is positive 6. So I'm hoping that kind of helps you understand why a negative times a negative is a positive answer. But again, if we go back to that original rule right up here at the top in words, whenever you're multiplying, in other words, getting a product of two integers with the same sign, you end up with that positive answer. Okay, now negative 4 times negative 7. As we've learned on the previous slide, when the signs are the same in the numbers you're multiplying, the answer is positive. So really all I have to figure out is what's 4 times 7. And 4 times 7 is 28. And we also know now that when the signs are the same and they're both negative, the answer is still that positive 28. Negative 5 times 2. Are the signs the same? Nope. So now we have a negative multiplied by a positive. So when the signs are different, do you remember? Is the answer positive or negative? Negative. And of course 5 times 2 is 10. Oops. Well, I guess I can just sort of slide down the... Funny, I guess that's one way of solving it. Just couldn't slide the little dot, so I slid the whole answer section down one to get it to negative 10 there. Sorry about that. So there we go. A positive times a negative is a negative. So when those signs are different, you end up with a negative answer. Uh-oh, now we have 3 numbers we have to multiply. So how do we handle this? Well, we handle it one step at a time. So we have negative 7. So that's times negative 3 times negative 4. So what we're going to do, just as we would with order of operations, just work our way from left to right. So we'll start with our negative 7 times negative 3. So starting with the negative 7 times the negative 3, well, 7 times 3 is 21. Would that be positive or negative 21? Well, it would be positive because, as we said earlier, when the signs are the same, we have a negative and a negative, we end up with a positive answer. But we still have to bring down this negative 4. So it's 21 times negative 4. Well, before I deal with the whole idea of if it's positive or negative, let's just do the multiplication. 21 times 4, let's see, 4 times 1 is 4, and 4 times 2 is 8. So I get an 84. But would that be a positive 84 or a negative 84? You already got that? Well, we have a positive times a negative. Well, a positive times a negative means the signs are different, and we end up with a negative answer. So signs are different, the answer is negative. So it's negative 84. Let's see if we can get that dot in the right place. There we go. Mr. Rodriguez. Oh, just like our literacy teacher next door, Mr. Rodriguez has $78 deducted from his pay every month and placed in a savings account for his retirement. What integer represents a change in his savings account for these deductions after 6 months? Wow, a lot of words, but I think we can get this. Here we go. $78 per month. And our other number we need is the 6 months. So he's going to do this for 6 months. Now, it's being deducted. Deducted means taken out of his pay. But let's make sure I'm doing this right. Mr. Rodriguez has $78 deducted from his pay every month and placed in a savings account for his retirement. What integer represents a change in his savings account for these deductions after 6 months? I believe what's going on here is really what happened to his savings account. So it looks like what we have here is $78 going into his savings account 6 times over 6 months. So we have 8 times 6 is 48. 6 times 7 is 42. Plus 4 is 46. There we go, 468. Now here's the question, are either of those numbers supposed to be negative? I don't think so, because while deductions to me sounded like it was going to be negative, $78 deducted, that sounds like we're a negative number. Really the question's asking about how does this affect his savings account. So the $78 is coming out of his paycheck, but it's going into his savings account. So the savings account's going to go up. So that's going to be a positive number. And of course, time is always positive. So I think that's going to be a positive 468. Yeah, I'm pretty sure we've got the right answer there. Okay, evaluate x, y, z. If x is -6, y is -2, and z is 4. So we're going to do -6 times -2 times 4. Again, we're just going to roll from left to right on this. -6 times -2, we already know if the signs are the same, the answer is positive. So 6 times 2 is 12. And even though they're both negative, it's still positive 12. Now we bring down our times 4, and 12 times 4 is 48. Positive times a positive. If the signs are the same, the answer is positive. Oh, look at that. We made it to the end. So thanks for watching. And of course, you probably already know my website, mattzigner.com. And just check out the questions on the website and get those done. And we'll see you guys next time. Thanks. Bye-bye. Thanks for joining me as we work our way through the 7th grade Math Connects textbook. Feel free to email me with any questions. My website is www.mattzigner.com. On my site, you'll find links to my math blog, some of my favorite educational sites, and lots of helpful information for students, parents, and teachers. See you next time.